Hi, welcome back to machine learning tutorial. In this video we will understand how to derive weight update equation in backpropagation algorithm. To derive the equation for updating weights in backpropagation algorithm, we use stochastic gradient descent rule. Stochastic gradient descent rule involves iterating through the training examples one at a time. For each training example D, descending the gradient of the error ED with respect to this single example. In other words, for each training example D, every weight Wji is updated by adding to it delta Wji. That is, Wji is always equivalent to Wji plus delta Wji. Here we are adding the delta Wji to Wji to get the Wji value. Now the question is, what is delta Wji? Delta Wji is always equivalent to minus n, that is the learning rate, multiplied by differentiation of ed with respect to Wji. That is, we are going to find the error with respect to dth example, and then we are going to differentiate it with respect to Wji, and then it is multiplied with the learning rate. We want to reduce the error, so we will take minus sign over here. So if we use this particular delta Wji, we will be able to get the new Wji. In this equation, the ed is the error on the training example D. That is half the square difference between the target output and the actual output or all the output units in the network. That is, error with respect to weight of dth example is equivalent to half the squared difference between the target output and the actual output, calculated output, or all the training output units in the network. Now here Tk is the target output of this dth example, OK is the calculated output. We will take it for all the output units and then we will get the error term here. Now we need to differentiate this error term with respect to Wji to get delta Wji, and then we can easily get Wji here. Now how to differentiate it, that is what we need to understand here. Before we go to that differentiation and all, first we will try to understand some notations used in this derivation. Xji is the ith input to unit j. Wji is the weight associated with ith input to unit j here. Net j is the summation term. While calculating the output, first we calculate the summation and then we will apply the sigmoid term. So rather than writing this summation term, we are just writing net j. Net j is always equivalent to summation of Wji xji over all I here. That is, I is the inputs and j is the current node in this case. Next, oj is the output computed by the unit j. Tj is the target output of jth unit. Sigma is the sigmoid function. Outputs, the set of units in the final layer of the network, is called as outputs. Downstream of j is nothing but the set of units whose immediate inputs include the output of unit j. That is, if I say downstream of j, the next layer units, they are nothing but the downstream of j here. So these are the notations we are going to use in this derivation. Now in this equation again, we want to calculate the differentiation of ed with respect to Wji. To begin, we notice that Wji can influence the rest of the network only through net j. That is, if you look at this particular network, if you calculate the net j or net 4, while calculating net 4, we use the input as well as the weight here, that is x41 w41, x42 w42, x43 w43. So in this net 4 or net j, you can say that this particular w41, 42 and 43 are used. These weights are never used any other part of this particular network. So what we do here is, we will use the chain rule and we will replace this differentiation term something like this. Differentiation of ed with respect to Wji is always equivalent to differentiation of ed, differentiation of net j, differentiation of net j with respect to Wji. So this you can cancel it, so that you will get the same term. So what we are trying to say is we are just using the chain rule to expand this particular equation. Now, what is net j? Net j is nothing but what? It's a summation of w into x here. So that is the summation of wji into xji. Now what I do is I will take this wji this side. It will become net j divided by wji. Once I do that, I will take this summation term this side. If I take summation term from one side to other side, it will become differentiation. The final answer is a differentiation of net j, that is this one, divided by differentiation of wji, which is equivalent to what? What is remaining on the right hand side? xji. So net differentiation of net j with respect to differentiation of wji is always equivalent to xji here. So this one can be replaced with xji. We will get differentiation of ed with respect to net j multiplied by xji here. This is the equation for the differentiation of error term with respect to wji here. Now what we need to do here is we will just put this particular differentiation term, this term in this delta wji. The delta wji will become minus n, that is as usual here. This term is written like differentiation of ed with respect to net j multiplied by xji here. xji is known to us because it is the input. The learning rate is known to us, but differentiation of error with respect to net j is not known to us. So we need to calculate this differentiation now. This is the expression what we need to evaluate. Once you evaluate this expression, we will be able to get delta wji. We can use this delta wji in this equation to update the weight here. So now our task is to find the value for this particular differentiation term. Now to derive the convenient expression for this one, we have to consider two cases here. The first case is the unit j is an output unit, that is the unit under consideration is an output unit of the network, and the unit under consideration, that is unit j, is an internal unit of the network. So there are two possible things are there. So we need to consider these two cases and then we need to derive it. That is, this j is the output unit. That's the first time we need to consider. The second time we need to consider j as the input internal unit, and then we need to find out what is the value of this particular expression. Now we will start with the first one where we have considered j as the output unit. Now similar to wji can influence the rest of the network only through net j, because while calculating net j we use wji. Similarly, net j can influence the rest of the network only through oj. oj is what? Output of jth unit. To calculate output of jth unit, what we do is we will take the sigmoid of net j. So net j is used while calculating the output of oj. Again we can use the chain rule and we can replace this differentiation of ed with respect to net j like differentiation of ed with respect to oj, differentiation of oj with respect to net j here. If we cancel these two things, we will left with the same equation again. Now we need to find out these two differentiation terms. So first we will start with this one, differentiation of ed with respect to oj. Differentiation of ed with respect to oj is equivalent to differentiation of ed. Ed is what? Half the squared error difference between the target and the actual output or all the output units. So that is what the ed term. So we will take this particular ed term here and then we will try to differentiate with respect to oj here. Now if you want to differentiate it, this constant term we will keep it outside first. That is the first thing we do. One more important thing here is we are trying to differentiate with respect to j here. So whenever the value of k will become j, then only this differentiation will become some value, otherwise it will be 0 here. So rather than considering the summation term, we just consider the value where k is equivalent to j. That is nothing but differentiation of 1 divided by 2 tj minus oj bracket square with respect to oj here. Because if you differentiate tk minus ok for any other value apart from j, you will get 0 here. So we need to consider only those target and actual output where k is equivalent to j. So that is what I have considered here. Now I will take this 1 by 2 outside, and then the differentiation of this one is 2 times tj minus oj multiplied by differentiation of Tj minus Oj with respect to Oj here. Again, if you differentiate this, differentiation of Tj with respect to Oj is 0. Differentiation of Oj with respect to Oj is 1 here. So 0 minus 1 is 1. So this 2 and 2 will cancel. The remaining term over here is, this is 0 minus 1, so it will be minus 1. So minus Tj minus Oj is the final answer. So this is for the first term here. For the second term, that is differentiation of Oj with respect to the net j, we need to find it something like this. Differentiation of Oj with respect to the net j. What is Oj? That is the first thing we need to understand. Oj is the output of jth unit. So how output is calculated? The output is calculated like first we calculate the summation term, that is net j, and then we will apply the sigmoid term here. That is, first we calculate the summation with that is nothing but net j, and then we will apply sigmoid, we will get the output term here. So this is how we can replace this particular equation. Now if you look at this equation closely, we have one very important property of sigmoid term. The property is, if we differentiate sigmoid term with respect to x, the answer is always equivalent to sigmoid of x multiplied by 1 minus sigmoid of x here. So this is the answer always we will get. So if you closely look at this particular equation, the x is replaced by net j, that's it. So we will get sigmoid of net j multiplied by 1 minus sigmoid of net j here. Now the question is, what is sigmoid of net j? Net j is the summation term, we are applying sigmoid, we will be getting the output here, that is nothing but Oj multiplied by 1 minus Oj here. So we got the value for this second term also. Combining these two things, we will get the answer for differentiation of Ed with respect to the net j is equivalent to minus Tj minus Oj multiplied by Oj into 1 minus Oj here. So this is the error term with respect to the output unit, where j is the output unit, you can say. Now we need to consider this thing, and then we need to find out Wji here. Delta Wji is equivalent to minus n differentiation of Ed with respect to Wji, we know that one. We have changed this particular thing to something like this, that is minus n differentiation of Ed with respect to the net j x ji. We have already calculated differentiation of Ed with respect to the net j, that is this equation. So we will put it here. This minus and this minus will get cancelled. It will become n into Tj minus Oj, Oj into 1 minus Oj multiplied by xji here. So this is the case. And next what we do here is this term, starting from, you can say that here to here, we will consider it as the Oj delta j here, that is delta j is equivalent to Tj minus Oj, Oj 1 minus Oj here. So the final term over here is n into delta j xji. So once you calculate this delta Wji, that is equivalent to this one, we will be able to modify the weight Wji here. That is Wji is equivalent to Wji plus this delta Wji. This is with respect to output node. Now the second case here is, we need to consider the hidden unit, that is this one. We have calculated the error time at this particular case, and we can modify these particular weights using those particular equation. Now you need to calculate the error term over here, and then using that particular error term, you need to modify these particular weights. Okay, that is the next question. So to do that particular thing, we need to remember one more thing. Whatever the error term we have calculated at 6th node is to be propagated back to 4th node as well as to the 5th node. Similarly, the error term calculated at the 7th node has to be propagated back to 4th as well as 5th node here. So to calculate this particular thing, that is the error term at error term due to net j, where j is the input unit, we need to calculate something like this. Whatever the error we got, that is due to the output unit, that is whatever the error we got over here, it is due to 6th node as well as 7th node. Whatever the error we will get at this particular node is also due to 6th node as well as 7th node. So what we write here is, we write summation of k belongs to downstream of j. Downstream of j is nothing but what? J is here. The downstream of j is 6 and 7. If j is over here, downstream of this j is again 6 and 7. So we will take downstream of all those particular nodes, that is in our case it will become 5 and 6. differentiation of ED with respect to net 6. Net k, you can say it will become net 6 one time, net 7 one more time. Differentiation of net k divided by the differentiation of net j here. So if you cancel these two terms, again we will get the same thing. But because this error term is due to all the output units, we have used this particular chain rule in this case. Now the question is, what is the value of this one and what is the value of this one? So first we will try to calculate the value of differentiation of ED with respect to net k. Here net k is what? Output unit. K is the output unit. You can see here. K is the downstream of j. J, the downstream units are output units. So k will be output unit in this case. Now whenever the j is output unit, we have already calculated this equation in the previous case. That is, the differentiation of ED with respect to net j is always equivalent to minus Tj minus Oj, Oj into 1 minus Oj here. So this is the equation we have already calculated when j is the output unit. If j is the let us say that in our case, net k is there. So what will be the value of this one? It will be nothing but minus Tk minus Ok, OK into 1 minus OK. That is how we can understand it. And one more thing what we have done here is we noted that this term removing that particular minus, we said this as a delta j here. Okay, so whenever j is the output unit, the error term with respect to that node is equivalent to this one, and this particular part we have replaced as delta j here. Now if we compare this with this one, what we are supposed to write here is delta differentiation of ED with respect to net k. Only difference is in place of j we have k here. So it will become, you can say that, as I said earlier, it will be Tk minus OK into OK 1 minus OK. So that is nothing but what? You can say that delta k, but here we need to consider minus here. So this term will become minus delta k here. So this will be minus, and this is nothing but delta k over there. Once you get the value for differentiation of error term with respect to net k, that is minus delta k, we need to find the value for this term. Now this term we will again use the chain rule. Differentiation of net k with respect to Oj, differentiation of Oj with respect to net j. This is the chain rule we have applied. If we cancel this particular term, we will left with the same thing here. Now we will try to find out the value for this one. So if you want to find out the value for this one, what we need to do is, I have shown it over here, the differentiation of net k with respect to Oj here. Net k is nothing but what? It's a summation term. From where to where the summation is coming? From j to k, or jth unit to kth unit, that is written as x kj and w kj here. So differentiation of x kj w kj divided by differentiation of Oj here. Now what is the value of these two terms, x kj and w kj? I just go back and try to show here. If you consider this particular network, x41, x51, x42, x52, x43 and x53, these are the direct inputs we are having, that is x1, x2, x3. These are the direct inputs we have. x41 is nothing but x1, x51 is nothing but x1. But for this one, x64, x74, x65 and x75, we don't have direct input. The output of fourth unit is input to this one, that is the output of fourth unit is nothing but x64, x74. The output of fifth unit is nothing but x65 and x75. So 5 is present at the second place, so you can say that it is O5, and 4 is present at the second place, you can say that it is O4 here. Now if you look at that particular thing, what is present at the second place here is j. The meaning of this one is it is Oj here. X kj is nothing but Oj. J is present at the second place, so we have taken Oj here. Now if we take the differentiation of this particular term, differentiation of Oj with respect to Oj is 1, wkj will only remain here. So this one is nothing but wkj here. Now what is the value of this one, that is differentiation of Oj with respect to net j? We have already calculated that one. Differentiation of Oj with respect to net j is always equivalent to, first we will replace this output term with respect to sigmoid and net j, that is output is always equivalent to net j. After that we need to apply sigmoid here. And then we have a peculiar property of this particular sigmoid, that if you differentiate the sigmoid term, you will get sigmoid term multiplied by 1 minus sigmoid term here. So here sigmoid of net j multiplied by 1 minus sigmoid of net j is always equivalent to oj into 1 minus oj here. So that is what we will put here. We will get the final output or the final equation for differentiation of ed with respect to the net j is this one. Now what we do here is we will take that particular thing and then we will put it into this equation, that is delta wji is equivalent to minus n differentiation of ed with respect to net j multiplied by xji. We know that or we have calculated just now the differentiation of ed with respect to net j. That particular term we will put here, but you can notice there is a minus here and this is a minus one more, so minus minus will get cancelled. We will left with n into oj minus 1 minus oj, that is this term, multiplied by summation of this particular term, and then this is the final xji here. So this is what the delta wji. Using this particular delta wji, we can update wji in this case. Next, one more thing we will try to do. We will keep this particular n and the last xji as it is. The in between whatever we have, that we will represent it as delta j, where j is the internal node in this case. So what is the value of delta j now? oj into 1 minus oj and summation of delta k wkj with respect to k belongs to downstream of j here. So this is nothing but the delta j equation where j is the internal node. We have calculated the error term for the output node as well as for the internal node. Using those particular things, we will be able to update these particular the weights in this case. In this video, what we did is we understood how the weight equations are derived using in backpropagation algorithm. We use the stochastic gradient descent rule for this particular purpose. In this case, we have divided this particular derivation into two parts. One is for the output unit and one more is for the input or the internal unit, and we got the equations for both the things. The algorithm is discussed in another video. The link for that video is given in the description below. If you like the video, do like and share with your friends. Press the subscribe button for more videos. Press the bell icon for regular updates. Thank you for watching.